Division. Division is the inverse operation to multiplication. So given any elements A and B, there exists a unique number elements C modulo x such that A divided by B is equal to C. This principle aids in the division of modular numbers. If A is divided by B equals to C, then A is equal to B times C in mod x. Okay, this understanding of this part would be clarified after we have gone through the examples. So, number 1, divide 6 by 7 mod 9. Solution is A 6 by 7. So, divide 6 by 7 mod 9. So 6 divided by 7 mod 9. So let's get 6 divided by 7. So say let's 6 divided by 7 be x. So 6 over 7 is equal to x. So when we cross multiply, to the 1, we cross multiply 6 is equal to 7x. This is what this part means. So remember, we are carrying out this division in mod 9, and here is mod x. Okay, so now we're going to solve. Now, I will carry out division in or modular arithmetic. Division under modular arithmetic is that when we get to this point in multiplication, we have to look for the multiple of the number, the mod number, and then look for the remainder. Okay, look for the multiple of the mod number that's closest to the value on this side of the equation, and then look for the remainder to add to that number to get the value here. But for division, we are going to get the multiple of 9. The multiple of 9 and add it to 6. So keep adding the multiple of 9 to 6 until we get the sum that is divisible by 7. So for instance, 9 times 1, 9 times 2, 9 times 2, let's stop here. 9 times 1 is 9. 6 plus 9, what does it give us? 6 plus 9 is 15. Now 15 is not divisible by 7, so we ignore this multiple. 9 times 2 is 18. 18 plus 6. 6 plus 18. 24. 24 is not divisible by 7, so we're going to ignore this multiple. 9 times 3 is 27. 27 plus 6, 33. 9 times 27. 27 plus 6 is 33. 33 is not divisible by 7. Let's try 9 times 4, 36. 36 plus 6 is 42. 42 is divisible by 7, so we go with this multiple. So the multiple of 9, that's the multiple of 9 is 36 when added to 6. When added to 6, that is divisible by 7 is what we're going to go by. So in this case, the multiple of 9 is 4, that is 36, rather the multiple of 9 is 36. So we're going to go with 6 plus 36 equal to 7x. Okay, so this will give us 42 equal to 7x. And then we solve the equation. So divide both sides by 7. 42 over 7. 7x over 7. And so x. 7 here 1, 7 is 6. 7 here 1, 7 here 1. So x is 6. So therefore, therefore 6 divided by 7 is equal to 6 in mod 9. 6 in mod 9. And B. Divide 2 raised to the power 3 by 3 raised to the power 2 in mod 5. Mod 5. So therefore, let's simplify this part. 2 raised to the power 2 is equal to 8. And well, this operation is to be done in mod 5. So 8 in mod 5, 8 in mod 5 is equal to 5 times 1 plus 3. So 8 in mod 5 is 3 mod 5. 3 raised to the power 2 is equal to 9. 9 in mod 5 is 5 times 1 plus 4. So 9 is equal to 4 in mod 5. So we're going to rewrite 2 raised to the power of 3 divided by 2 raised to the power of 2 is equal to 3 divided by 4 to be done in mod 9. 3 divided by 4 will be equal to x. So 3 over 4 is x. So 3 is equal to 4x. We apply the same principle. So what we're going to do is that we're going to get the multiple of 9 when added to 3. If it's divisible by 4, then practically what we are looking for is that we want to repeat to get the multiple of 9 that when it's added to 3 would be divisible by 4. So let's see what 9, what we have in here. 9 times 1 is 9. 9 times 3 is 12. Okay, so 9 plus 3 is 12. 12 is by 4, so we go by 9 plus 3 equals to 4x. 9 plus 3 is 12, which is equal to 4x, and x equal to 3. Let's just check the next multiple. 9 times 2. 9 times 2 is 18. 18 plus 3 21. 21 divided by 4 is 21 divisible by 4, So since we've gotten our answer, adding 21 is divisible by 4. That means this division would have gotten 2 values. But now since the next multiple is not divisible by 4, we only have one value for x. So we say therefore 2 raised to the power 2 divided by 3 raised to the power 2 equals to 3 divided by 4. And this is equal to 3 mod 9. Or we say therefore x equal to 3 mod 9. That's the answer. Number 3 times 2 divided by 5 mod 7. So we have two operations here, division and multiplication, all to be carried out in mod 7. So first of all, let's do the multiplication. 3 times 2 mod 7. So 3 times 2 is equal to 6, which is 6. 3 times 6 is equal to 6 mod 7. So now 3 times 2 divided by 5 simplifies to 6 divided by 5. So 6 over 5 is equal to x. And now 6 is equal to 5x. So since we are working with modular arithmetic, we're doing this in modular arithmetic. What this implies is 6 equal to 5x. Look for the mod. What number are you carrying out this division? What mod number? Mod 7. So look for the multiple of 7 that if you add it to 6 will be divisible by 5. The first multiple of 7 is 7 times 1, which is 7. 7 times 7 plus 6 will give us 7 plus 6, 13. 13 is not divisible by 5, so we ignore it. 7 times 2, 14. 14 plus 6, 20. So 20 is divisible by 5. So we're going to accept this one. So this is what we want. 7 times 2 is 14. So 6 plus 14 is equal to 5x. And now 6 plus 14 is 20. 20 equal to 5x. X equal to 4. So 6 equal to 5x. We get 6 plus 14. 14 is a multiple of 7. Multiple of 7 that when 6 added to it is divisible by 5. So 6 plus 14 equals to 5x. 6 plus 14, 25x. So x equal to 4. Therefore, 6 divided by 5 6 divided by 5 is equal to 4 mod 7, or we say x equal to 4 mod 7. You calculate the following mod 5, 29 divided by 2 mod 5, 29 divided by 2 is equal to x. 29 over 2 equal to x. 29 is equal to 2x. Okay, so now multiple of 5 when added to 29 would make it divisible by 2. So let's see, multiple of 5 is 5 times 1 equal to 5, 5 times 2, 10, 5 times 3, 15, 5 times 4, 20. So let's see, 5 times 1 is 5, 5 times plus 29 plus 5, 29 plus 5 is 34, and 34. So if you add, okay, so 5 times 1, 5, we add 5 to 29, we get, going to get 34. 34 divided by 2, is it divisible? Yes. So we come over here and see. Okay. So this is 29 plus the multiple of 5 that will make this, when added to 29, will make it divisible by 2 is 5, 2x. So 29 plus 5 is 34 plus 2x. And x equals to 34 over 2. We want to get 17. Therefore, x equals to 17 in mod 5. So what that means is that 29 divided by 2 is 17 in mod 5. Number 2, which is B. Nine divided by 4. So in mod 5. Mod 5. 9 divided by 4 is equal to x. 9 over 4x. 9 is equal to 4x. So multiple of 5 when added to 9 will be divisible by 4. 5 times 1 is 5. 5 plus 9. 9 plus 5. 14. 14 is not divisible by 4. 5 times 2 is 10. 10 plus 9. Okay. 5 times 2 10. 10 plus 9 is 19. 19 is not divisible by 4. So 5 times 3 is 15. 15 plus 9. 10 plus 9. 24. 24 is divisible by 4. So we go with this multiple. So 5 times 2 is 15. That will be 9 plus 15 is equal to 4x. 9 plus 15. 15 plus 9 is 24. 24 is equal to 4x. So x equals to 24 over 4. 4 here, 1, 4 here, 6. Therefore, x equals to 6 in mod 5. C 11 divided by 8 mod 5. So 11 divided by 8, let's make equal to x. So 11 over 8 equals to x. 11 is equal to 8x. So multiple of 5, get the multiple of 5, add this to 11. Let it be divisible by 8. So 5 times 1, 5. 5 plus 11, 16. 16 is divisible by 8. So we go by that. 11 plus 5 equals to 8x. 11 plus 5 is 16 over 8x. So x is equal to 2. Therefore, x is equal to 2 in mod 5. Mod 5. Number 2. Where possible, find the values of the following in mod 4. 2 divided by 2. 2 divided by 3. Mod 4. 2 divided by 3 equals to x. 2 over 3 is x, and 2 is equal to 3x. So now, multiple of 4. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. I'm going to stop here. So the multiple of x, the multiple of 5, 4. Then when added to 2, it will be divisible by 3. 4 times 1 is 4. 4 plus 2, 6. 6 divisible by 3. So when you get that, 2 plus 4 equal to 3x. That's 6 equal to 3x. And x equal to 2. So therefore 2 divisible by 2 equal to 2 mod 4. Or we say x, x is equal to 2 mod 4. Either of them squares. Let's see. Oh, so b, b is 2 divided by 2 in mod 4. 2 divided by 2 is also equal to, okay, divided by 2. So we say that's 2, let's divided by 2 x. So 2 over 2 equal to x. At this point, we can easily divide. So 2 here, 1, 2 here, 1, 1, 2. So 1 is equal to x, x equal to 1, or 1 in mod 4. So let's see. We didn't use multiple of 4 and add it to 2. Add it to 2 to determine if it's divisible by 2. So let's see if we're going to get value from that. So we say, or we come here, let 2 divided by 2 equal to x, which means 2 over 2 is equal to x. So 2 is equal to 2x. So multiple of 4 when added to 2 will give us, when added to 2, this will make the sum to be divisible by 2. Now 4. So 2 plus 4 is equal to 2x. 2 plus 4 is equal to 6x. So x is equal to 2 in mod 4. So what do you just have? You have this x equal to 1 when we divide straight away, and then x equal to 3 when we apply the principle of getting the multiple of 4 and add it to the number here, or add it to the number here. And since the sum is divisible by 2, we divided 4 that to get 3. So this implies that x has 2 values. This implies that x has 2 values, which are therefore x equals to 1 or 3. So 2 divided by 2 and 4. Then let's 3 divided by 2 equal to x. 3 over 2 equal to x. And 3 is equal to 2x. Okay, so multiple of 4 when added to 3 will make this side divisible by 2. So 4 times 4 plus 3 is 7. Cannot be divided by 2. 8 plus 3 is 11. Cannot. 12 plus 3 15. Cannot. 16 plus 3, 19 cannot be divided by 2. 20 plus 2, 23 cannot be divided by 2. So if you go on and on, you discover that you are not going to get any multiple of 4 that can be divided by 2. Any multiple of 4, when added to 3, it will give you a sum that will be divided by 2. So you see, x, therefore, okay, so since there is no multiple, of 4 that would be added, to 3 to make the sum divisible by 2, it implies that x has no value. Implies that x has no value in mod 4. So when it comes to division, there's possibility that some divisions don't have value. So and the reason is that division is still advancing. It's not yet it's not something that okay, at this point, let's just say that at this point division is still advanced. So there are times that you carry out division in some bases, in some mod, and you won't have a value. You come to this point where you can't get multiple when added to a number, and that will make it divisible by what you have on the other side of the equation. So at that point, you just say that there's no value, so you stop there. So just bear it in mind that division at this point is still advancing, and possibility that some divisions, modular division, don't have value. So here are two facts that you need to note. Note in example 2b, that's this part. Note in example 2b that division in modular arithmetic may give more than one value, or possibly no value at all, just like example 2b shows. Again, 2. Not all divisions involving modular arithmetic have values. Division at this level is advanced. It means that at this level, division is higher than the scope of division in modular arithmetic covered at this level. So once you come to divisions that do not have value, you just have to stop there and indicate that it doesn't have value, because the process is still higher than this level. So that's